In today's lesson, we're going to cover our last form of integration, which is integration by trig substitution. So when we're doing integration by trig substitution, our questions are going to be in the form of the square root of a squared minus x squared, the square root of x squared minus a squared, or the square root of x squared plus a squared. And if they are in those three forms, we're going to look at these three rows in our table to help us with the integration. So it might be advantageous for you to print off this table so you have it at your disposal. Okay, let's take a look at this first example. So in our first example, you notice this is of a constant squared minus x squared, so it's of the form the square root of a squared minus x squared. So obviously in this case a squared is 36, so a is going to be equal to 6. So looking at our table, the substitution we're going to use is x is equal to a times the sine of theta. So x is going to equal, a would be 6 sine theta. So if we were to go and draw a diagram here, I have theta down this corner. If I divide both sides by 6, sine of theta would be x over 6. And to figure out this side, it would be 6 squared, which is 36. 36 minus x squared would be the length of my third side. Now, I want to come up with an expression for the square root of 36 minus x squared in terms of theta. Well, if I take the cosine of theta would be the square root of 36 minus x squared over 6. And if I bring the 6 up to the other side, I get 36 minus x squared under the root sign equaling 6 cos theta. Up here, if I take the derivative of x, I'm going to get 6 cos theta d theta. And now I'm able to do my substitution because I know what dx is, and I know what the square root of 36x squared is. So this is going to be, in place of dx, I'm going to put 6 cos theta d theta. And in place of the square root of 36 times x squared, I'm going to put 6 cos theta. So now my 6 cos thetas are going to cancel, and I'm just left with the integral of 1 d theta, which is equal to theta plus a constant. Now, my original question was in terms of x, so I have to get theta back in terms of x. So if I go from here, I know that x over 6 is sine theta, and if I take the arc sine of each side, I'm going to get theta equals arc sine of x over 6. So in place of theta, I'm going to put in the arc sine of x over 6 plus a constant, and there would be my final integral. Now, this particular question, we could have done it the same way we did it back in Chapter 4, but in the preceding questions, the method we used in Chapter 4 will not work. So if we take a look at our next example, we have 1 over the square root of 16 minus x squared times x squared. So again, this is of the form the square root of a squared minus x squared. So x, therefore, is going to be 4 sine theta. And if we draw our diagram, here's theta. If I divide by 4, I get opposite over hypotenuse sine. So therefore, this side here is going to be 16 minus x squared. And if I go cos theta is equal to the square root of 16 minus x squared over 4, and therefore 4 cos theta equals the square root of 16 minus x squared, and dx is 4 cos theta d theta. So now I need to make substitutions for dx, for x, and the square root of 16x squared. So in place of dx, I'm putting 4 cos theta d theta. In place of x, I'm putting 4 sine theta, and that is squared. And in place of the square root of 16 minus x squared, I'm putting 4 cos theta. So now the 4 cos thetas will cancel out, and I'll be left with the integral of d theta over, if I square the 4, it's 16 over sine squared theta, which 16, or 1 over 16 is a constant. If I move sine squared up to the top, it becomes cosecant squared theta. And now we have to look at what the integral of cosecant squared theta is. Well, if you remember, the derivative, the derivative of cotangent is negative cosecant squared. So the integral of cosecant squared is negative cotangent theta plus a constant. And now I want to get cotangent theta in terms of x. I'm going to go back to my diagram. And cotan theta is equal to adjacent over hypotenuse. So cotan theta from my diagram would be the adjacent side, which is 16 minus x squared over the opposite side. So I'm going to move that negative out front, so it's negative 1 over 16. In place of cotan theta, I'm putting 16 minus x squared into the root sign over x plus a constant, and there would be your final answer. Okay, in our next example, we are going to take a look at the square root of 1 over 4 plus x squared. And 1 over 4 plus x squared follows the pattern of, if we look back at our table here, of my second row. So, in this particular case, I have 2x, because the square root of 4x squared is 2x, is equal to 3 tan theta. So therefore x is equal to 3 over 2 tan theta. And if you were to isolate tan theta to draw our diagram, tan theta would be 2x over 3. So this side would be 2x, this side would be 3, and this side would be 4x squared plus 9. So in place of the 4x squared plus 9, we are going to say that the secant of theta is going to be the hypotenuse over the adjacent, so it's going to be 4x squared plus 9 over 3. And if I bring the 3 up to the other side, now I have a substitution to get rid of the square root of 4x squared plus 9. And if I take the derivative of this, I'm going to get dx is equal to 3 over 2, and the derivative of tan is secant squared theta d theta. So now if I make my substitution, in place of dx, I'm putting in 3 over 2 secant squared theta d theta. And in place of the square root of 4x squared plus 9, I'm putting in 3 secant theta. So this will simplify to be the integral of 1/2 secant theta d theta. So 1/2 is a constant. Now, if you look back at last lesson, we did have we gave you the integral of secant theta, and the integral of secant theta is ln, the absolute value of secant theta plus tan theta plus a constant. So now all I need to do is I need to substitute and get everything in terms of x. So this is going to be ln, the absolute value, while secant theta, if I isolate secant theta here, it would be the square root of 4x squared plus 9 over 3 plus, and in place of tan theta would be 2x over 3 plus a constant, and that would be your final answer for this integral. Okay, let's take a look at the next one. So this one again follows the pattern of a squared plus x squared. So therefore x in this particular case is going to be 3 tan theta. So again, according to my diagram, there's theta. Tan of theta would be x over 3. So this is going to be the hypotenuse, which is x squared plus 9. So again, to isolate x squared plus 9, I could say that secant theta is equal to the hypotenuse over 3. Therefore, 3 secant theta is the square root of x squared plus 9. And if I take the derivative here, I'm going to get 3 secant theta d theta. So now I can make my substitution. So I have this 4, which I'm just going to leave right now. And in place of the dx, I'm putting in 3 secant theta d theta. And in the bottom, in place of x, I'm going to put 3 tan theta. And I have to square that. And in place of the square root of x squared plus 9, I'm going to put in the 3 secant theta. So if we simplify this, I'm going to get 4 times 3 secant theta d theta. And on the bottom, this should be squared, sorry, not cubed. I'm going to get 9 tan squared theta times 3 secant theta. So therefore, my 3's are going to cancel. The 4 over 9 is going to come out front. And I'll be left with the integral of secant theta over tan squared theta d theta. And if I manipulate this using my trig identities, this is going to be 4 over 9. Secant comes down to the bottom to become cos theta. This is really sine squared over cos squared. And if I take it up to the top, it becomes cos squared theta over sine squared theta. And if I simplify this, this becomes 4 over 9, the integral of cos theta all over sine squared theta d theta. Now at this point, I have to do a u substitution. I am going to let u equal sine theta. Therefore, du is equal to cos theta d theta. So this is going to become 4 over 9, the integral of du over u squared, which is really u to the minus 2. And if I integrate this, this is going to be 4 over 9, u to the minus 1 divided by a minus 1, which I'll put out there, plus my constant. So this becomes negative 4 over 9u plus a constant. And putting back in u, it's negative 4 over 9 sine theta plus a constant. And going back to my diagram, sine theta would be x over the square root of x squared plus 9. So that is going to be negative 4 over 9 all over x over the square root of x squared plus 9. And finally, if you multiply by the reciprocal, you're going to get negative 4 over 9 times the square root of x squared plus 9 over x plus a constant. So that one took a whole ton of work. And again, you might want to just pause the video and go through that and take a look at that final answer again. Okay, we'll just stop here for a second, and then we will continue with the second part of this lesson in our next video.